Welcome to Area Between the Curves 101. In this video, we will be showing you how to find the area between curves. So, before we do that, we're going to give you some basic definitions and techniques in order for you to solve the following problems. So, to begin, one should know that generally, the area between the curves is equal to the integral of a function minus the integral of the other function, which is demonstrated by a equals the integral of f of x minus g of x from a to b. So that's your basic setup with areas between the curves. But when you solve these problems, there's two techniques that you should follow, depending on how your graph is laid out. The first one is top function minus bottom function. This means that in the example, f of x is the top function and g of x is the bottom function. So you would subtract g of x from f of x, which is shown next to it from the integral from a to b of f of x minus g of x. The second technique is right function minus left function, which is demonstrated below also. G of x is the rightmost function, and f of x is the leftmost function. So you would take the integral from a to b of g of x minus f of x. So the two basic techniques to summarize what I just stated is top minus bottom and right minus left. To find a and b, you set the two functions equal to each other and solve, which is demonstrated below also. So as you can see, I have two functions, y equals x plus 1 and y equals negative x squared plus 1. When you set them equal to each other, you solve for 0, as you can see. So then you have x squared plus x equals 0. You can factor out an x to get x times x plus 1 equals 0, and then you find your a and b, which are 0 and negative 1. And then demonstrated to the right is the integral and how it would be set up. So it goes from negative 1 to 0 of f of x.
Welcome to Mackenzie Teaches Math. Today, we will be working on area underneath the curve so we can figure out how large Blinky is. Blinky is represented by the function f of x, which is right here. And so to find how big Blinky is, we're first going to find the bounds of the function. So to do this, we have to find where f of x crosses the x-axis. So we set f of x equals 0. Then we move the 4 across, so we have negative x minus 2 squared equals negative 4. Divide a negative 1 across. Take the square root of both sides. Then solve. Now these are the bounds of our function, so then we put them into our integral, which is this thingy. A being our first point on the bounds, and B being the last point. So on our problem, A equals 0, not A, it does. B equals 4 of our function, which is 4 minus x minus 2 squared. Now you can put d of x in there. Then we take the antiderivative of the function. So the antiderivative of 4 is 4x, and the antiderivative of x minus 2 squared is 1/3 x minus 2 to the third. Then we take f of b minus f of a. So we put in 4 right away, 16 minus 1/3, 2 to the third, minus f of a, which is going to equal 8/3. Then we get a common denominator. 48 over 3 would be that, minus 8/3, minus 8/3, which is going to equal 32/3. And that is the area underneath the curve. So Blinky is 32/3 units squared. Thank you.
Today we are going to find the area of Winky, which is the area between the curves y equals 2 and f of x equals x squared minus 2. In doing this, the first step we need to take is finding the bounds of our function. So to do this, we set the two functions equal to each other. So you have x squared minus 2 is equal to 2. You add a 2 to each side, so you have x squared is equal to 4. Take the square root, so you have x is equal to plus or minus 2. These are the bounds of our integral. Our a, which is on the bottom, is negative 2 because that's the lower value, and then 2 is our b because that's the higher value. And then you do the top function, which is y equals 2, minus the bottom function, which is x squared minus 2. 2 minus x squared minus 2, which can be simplified to the integral from negative 2 to 2 of 4 minus x squared. Now we find the antiderivative, which is 4x minus 1/3 x cubed, from negative 2 to 2. Now we plug in each of these values and do f of b minus f of a. So you have 8 minus 8/3 minus negative 8 plus 8/3, which can be simplified to 24/3 minus 8/3 minus negative 24/3 plus 8/3, which is 16/3 minus negative 16/3, which turns into adding, and you get 32/3 units squared, which is the area of Winky. Alright, now that you've learned how to do these problems, we want you to give it a try. So please pause the video after the instructions and give it a go. In this problem, we want you to find the area between f of x is equal to x plus 1 and g of x is equal to negative x squared plus 1. On the right, you can see a graph, but you should try to sketch that on your own. Alright, so now that you've given it a try, let's compare your answers to some of ours. Did you get A is equal to pi, B it is equal to 7.32, C it is equal to 1/6, or D it is equal to pi over 7? What's that? You got C? Correct, that's the right answer. Let's review the steps just to make sure you're understanding. Alright, in this problem, to find the bounds of your function, you set the two functions equal to each other, and then go through the process of solving it, where you would get x equals 0 and x equals negative 1. Then you take the integral of the top function minus the bottom function, so you have negative x squared plus 1 minus x plus 1. Then you take the antiderivative and plug in your bounds, and you'll get 1/6 units squared as your answer. Alright, here's another problem just to test your knowledge. In this, we would like you to find the area between x equals y squared and x equals 2 minus y. Again, on the right, there's a graph sketched, but please try to attempt this on your own. Now pause the video and give it a go. Alright, you got an answer? Let's see what you got. Did you get A, 74, B, 4.97, C, 27/6, or D, mx plus b? You got C? Correct, that's the right answer. Let's review the steps to make sure you know what you're doing. Alright, so again, you set the two functions equal to each other to find the bounds, in which you get y is equal to 1 and negative 2. Then you take the integral from negative 2 to 1 of 2 minus y squared. This is because you do the rightmost function minus the leftmost function. Then you take the antiderivative and then plug in your bounds, and you get 27/6 units squared.